So what we're going to do here is, no matter what, we want to take the line, well, just going to do a little block for this so that it's easy to enable or disable at some point. So we're going to activate the line material. Then we're going to do pretty much what we've done up here. I need to get... I'm still being passed in vertex attributes and stuff like that. This is horrible stuff that we need to get rid of at some point. So what I want to do is I want to get a vertex attribute. Vertex attribute, which we'll get by calling the material get attribute vertex position. And then I also want a color attribute. And this is going to be called color at vertex color. And it doesn't exist yet, so we need to add that. So in addition to all of this, we have one called vertex color. Vertex color. And in the actual implementation, texture. This one is get attribute vertex color. And what we're looking for is, if we don't have the color set, we ask OpenGL for the address of the color input, and then we return that. And we need to initialize it as well. So by default, the vertex color is -1. Great, so we've got that done. And grab those two. Then we can bind our line buffer. Basically going to be doing a lot of this stuff here. So what we want to do is we want to bind our line buffer. And then I want to associate, just going to quickly remove them. So first of all, the vertex data and then the color data. Both of these are floats normalized, and this is line vertex data that we're iterating over, so we need that stride. And then we need to go for line vertex data for offset for the vertex coordinates, and then offset for the vertex colors. And I probably call it something else. Offset color is going to be offset vertex colors. And I think my graphics card is acting up to it right now. Well, at least my mouse cursor was back for a moment. There we go. So vertex colors. So with that done, we can set this on vertex normal colors. We need vertex colors. That sets up the color attribute, and then we do a draw raise saying GL line. GL lines. That should do lines with that. Now we need to set up our line material, and right now we're just going to do this the easy way. We're going to say that line material is the material called line. Oh, need to not be a reference in this case so that we can act. And now we're instantiating unknown structures, so we can't just reference it, we actually have to include it. If I do that, we now have GLES material included. So we have unknown symbols, which are these vertex chord things. So we need to go into our chunk renderer, where we have these wonderful things here. So for our line vertex data, the offset for the vertex coordinates is the offset of x in line vertex data, and offset for vertex colors is the offset of the R element, because R is the first one of the colors. There we go. So we've got that set up. Now we need to introduce the wonderful little material. And what we want to do is we basically want to copy the stone material, call it line instead. And this time we don't have any textures, so it's just empty. I want to use the base vertex shader, but I want to do a line fragment shader. So we're going to do a line fragment shader. Yeah. Now I need to actually have a line vertex shader as well, because I need to interpolate colors over it. So I need a line vertex array, and I need to say this is an empty array. So the line here has model view and projection transform. It does not have a vertex. It does, however, have it has a color. It does not have a normal. It has a color instead. And we're going to output a varying color. And we're not going to do anything with the material. So what we do for normal is for color is we just output the color we got in. And we output our GL position, and then we ignore everything else. There we go. And the fragment shader takes in a varying color. It does not have a fragment. We don't care about lighting or anything like that. And the output fragment color is simply the color we got from interpolating across the vertices. This is probably going to go horribly, horribly wrong, but let's see what happens. Attempting to access detached array buffer. Well, I'm definitely getting some materials loaded. So that's one little issue here, is that right now I am instantiating a material for every single chunk renderer. Not that bad, but it needs to be taken care of at some point. Reminds me I can kill off this code. So what's going on here is most likely that this size is definitely wrong. This is the line buffer data size. Attempting to access detached array buffer. Let's try and see what happens with that. Oh, and I need to use the line material here. Get these things out of that. Okay, let's switch over, reload, see it fail again. Do we, if we inspect and look at the JavaScript debugger, have anything more to see? Not really a lot. We're aborting somewhere. part of the problem is probably that we haven't actually added any data into the line buffer. That would at least give us a little bit of a problem. So we're going to find that line buffer as well here. Transfer line buffer data into it, and that's line vertex data here. So now we actually transfer data into that line buffer. Switch over again and rerun it. Yeah, I'm still getting attempted to access detached array buffer. Okay, time to do best thing ever, which is search Google. Okay, apparently my copy paste did not work. So this looks more like a JavaScript thing than a OpenGL thing, which makes it all the more interesting. So no heap copy might do something, because I know we're compiling with these options. Okay, let's try adding this. So compile options are here. So no heap copy. We compile with that. We try running it. That seems to fix the problem, but we're not really getting any lines rendered. Probably something to do with setting a line width. Possible, would be my guess. So we've got our line stuff here and our line material. Let's just GL line width 1. Note. See if that starts rendering some lines. So here in the line material, GL line width 1. Still no red lines. Okay. Google time. GL draw array. GL lines. Data, transfer that data, okay, transfer the problem. I mean, looks reasonable. Let's try that again. Okay. Quick little things I'm thinking here. I am not finding a single uniform at all into that vertex shader. It is not going to work in any way, shape, or form. So I need to put in the local model transform. I also need to, so that model transform here is our line material. Get uniform model transform. So am I also being passed in? Yeah, I'm getting the current view and projection transform. So I also want to pass in for our line material. I want to get the uniform view transform, and that's my current view transform. And I also want to do our projection transform. So we have a current uniform projection transform. I want to pass in the current projection transform. That should set all the state up. So we're going to switch over and refresh. So we have some nice red lines now. So that's a good start. So now we just need all the edges. Like this is one set. Then we have a pair where this is positive. Then we have a pair where this is negative here. So that's one direction of lines. Actually, I don't need all of these because chunks will overlap. So no reason to do that. Every chunk essentially only needs to render 3 lines each. So if we go with that, the first one is the one we want to keep. Then we just do stuff like this. That should get the rest of it. 5, and we refresh this. Now we can see where our chunk boundaries are. And there's no excuse for this floater still being here. So the question is, why is it? So let's just quickly count. So there's one sticking out here. This is really, really hard to count. I'm just quickly gonna do a little modification of the fragment shader for face here. Because we have a really, really weak ambient light, I want to just increase the ambient light a bit here. So we need to clean for that to take effect. So we're just compiling now, waiting for that to happen. And we've compiled, we refresh. So now it's a little bit easier to see what's going on. So we have this thing here. It is 5 blocks here. We have 5 blocks in the middle and 1 block at the end, so that's 11 blocks. So it should get removed by the 16 block limit. So there's definitely something wrong with the floater removal. And I am just going to close every editor window here, because I'm a little bit tired of looking at them all. So let's take a look at our floater code again. So the current condition is if our open list is empty. Then we go through all the blocks in our block list and we set that X, Y, and Z there to 0. So another condition that I'm currently missing is the push this if it's not an air block. Because if it's just an air block, then we don't want to. Then we don't want to count it. And currently we're doing that. So that means everything is connected to a whole lot of other stuff because air blocks count as well. So if get of minus x minus 1 y z is not 0, then if we haven't seen it yet, push it on. And this is plus. This is nothing, and then it's minus here. This is y plus. Entity, what do you need a plumber for? Did I say something stupid and I missed it, or am I just a little bit slow today? There we go. Let's try compiling that as well. And one more time. Yay, fewer floaters. So this floater touches a chunk border, that's why it's not removed. Same thing goes for this one. Ah, yeah, okay, I get it now. Floater removal isn't working. Call a plumber. Toilet humor at its best. So this floater is probably this floater is too big to get removed at current. That one that's against the chunk border. I can really feel the lag because of the lines. OpenGL does not like drawing lines. So that's wonderful. I think we're gonna increase the floater limit a little bit. I think we're gonna go for something like, how about 128 for a float limit? So it has to be really big floaters before we actually keep them. Let's try and refresh that. Actually, and saw something interesting here. We have a small error in our chunk renderer. So I want to just take a look at that. So what's interesting here is that when we rewrote it, I had a moment where I was thinking something a little bit stupid. So you'll notice that we're doing from like -8.5 to 8.5. So that's a 17 wide bit. It shouldn't be 17-bit wide. It should be just 16. So we actually should be only doing till 8. But the reason why I'm doing 8.5 is because I've offset all the blocks by a half without thinking about it, because I was thinking like I want to have a center block in every chunk and have that around 0, 0. But of course there is no center chunk, because with a 16 wide chunk you can't divide that into 2, or you can only divide it into 2 equal halves and then you don't have anything. And Regan, I am not going to try and just draw the lines in the current chunk and the chunks around me. It's only a debugging aid. I don't care if performance sucks with it on. At least not now, because that part will just make life difficult. I don't really have a good way of getting where is the player right now at the moment, so that's not going to happen. Anyways, so this division by half is all the way down through here where I'm doing edges divided by 2 float, because that's 17. What I want instead is I want the size of a chunk instead, so I want the chunk size here. So now we just have to do a nice little search and replace. So what we want to do is we want to look for this string, and I want to replace it with this one. And I'm not just saying remove them all because I want to be sure it's only the right ones. So I'm pretty sure it doesn't say this anywhere else. So let's just go with that. Nothing like coding by search and replace. Okay, so a little thing up here, you can't just say 8f, you have to say 8.f, because it needs to be a floating point number. And just because this annoys me, I want to do set it up like that. That looks a lot better. Try that again. Switch over, refresh this. There we go.